Alright, in this video we're going to learn how to solve a radical equation. And a radical, remember, is just a different kind of root. It could be a square root, a cube root, or any kind. I have three rules up at the top here that just write them down, and let's kind of jump in with these examples. So on this first problem here, we have to solve for x. If we're going to solve a radical equation, we have to get rid of this root right here so we can get x out and get it by itself. So our first goal is to get the square root by itself so we can cancel it. These first few steps should be real simple, real basic for you guys. We're going to subtract 2 and then divide by 4. So we subtract the 2, we divide by 4. I'm going to go ahead and just skip those steps and write down. It's going to be the square root of x minus 5 is equal to 3. Okay, so we get the square root by itself. I'm not showing those steps because you guys totally know how to do that already. What we want to do now is cancel out this square root right here. And the way you cancel out a square root is by squaring both sides. We are going to bring an exponent of 2 onto both sides of our equation because that's going to cancel our square roots. So we will end up with just x minus 5 over here. And now it's going to equal 3 squared, which is 9. Once we do that, the square root is gone. We're just going to finish solving for x, and we will get, at 5, we're going to get x equals 14. So we got the square root by itself, and we canceled it with an exponent. Same idea on the second problem right here. So we have 5 times a cube root on this one. We're going to divide by 5 to get rid of the roots. Sorry, to get rid of the 5 out front. Now we just have the cube roots of 7 plus x is equal to negative 4. If you want to cancel a square root, you square both sides of the equation. If you want to cancel a cube root, we're going to cube both sides. So we're going to raise both sides to the 3rd power. So now we're going to be left with just 7 plus x over here, and negative 4 to the 3rd power is going to be a negative 64. And then it's easy. We just subtract 7 to get our final answer. We're going to get x equals negative 71 for this one. Okay, one more problem for this video, and it's over here. We have another square root problem. We are going to start out on this one by subtracting our 13. We want to get the square root by itself. Once we do that, we're going to get the square root of x plus 6 is equal to negative 5 right here. Now, for those of you who read the rules at the beginning, you may already know what we're going to do with this here. But I'm going to go ahead and try solving this anyway. If I square both sides right now, I'm going to get just x plus 6 equals positive 25, and I'm going to get x equals 19. This 19, though, does not actually work if we plug it back into the original equation. I'm going to show that right over here. So we're going to have the square roots of 19 plus 6, and then a plus 13, and we want to see if that actually does equal 8. Well, this guy is the square root of 25 plus 13. That's a 5 plus 13. 5 plus 13 does not equal 8. That does not work. This answer, it's kind of like a fake answer, and the vocab word for that is called an extraneous solution. It's an answer you get when you solve a problem that doesn't actually work when you plug it back in. The reason, this is kind of a weird new thing we're talking about, but the reason is right here on this step written in black. Before I'll erase this right here so we can see it better. We had a square root equal to a negative number. Square roots cannot equal a negative. When you have an even roots, they have to equal 0 or a positive number. On the second one, we had an odd root. We had a cube root equal to a negative. Totally fine. But on this last one right here, square roots can't equal negatives. Instead of solving this problem, what I should have done at this step is seen, oh, square root by itself equal to a negative, no solution. You can save yourself the trouble if you've noticed it. If you finish solving it, you're getting an answer that doesn't actually work, called an extraneous solution.